Netflix writes 3 million records per second to their database. Instagram stores over 1 billion users on PostgreSQL for years. And Twitter serves 300,000 timeline requests per second from Redis. 3 of the biggest platforms in the world. 3 completely different database choices. Why? It's not because one database is better than another. It's because each company has fundamentally different access patterns. And the database that's perfect for one would be a disaster for another. So today, I'm going to reverse engineer the database architecture of all 3 companies. Not just what they use, but why they chose it, what trade-offs they accepted, and what would break if they had chosen differently. And by the end, you will have a mental framework for making these decisions yourself. Whether you are building a startup or answering this in a system design interview. Let's get started. Let's start with Netflix. Think about what happens when you open the app. Netflix needs to track what you're watching, what you paused, what you searched for, what you hovered over, what device you are on. Every single interaction generates data. Multiply that across 260 million subscribers worldwide, many watching simultaneously, and you get a write volume that would crush most databases. We are talking 3+ million writes per second. Their choice? Apache Cassandra. Netflix's primary database for most of their services is Cassandra. And the reason comes down to one thing. Cassandra is built for write throughput at horizontal scale. Here's the secret most people don't know about Cassandra. At its core, it's essentially a distributed hash map. So when you write data, Cassandra hashes your partition key and routes the write to the responsible nodes. The write goes to an in-memory structure called a mem table, gets an acknowledgement, and the client moves on. No logs, no coordination with other nodes for the primary write. This is why it handles millions of writes per second. Each write is essentially an append operation with minimal overhead. But here is what Netflix gave up. Cassandra's read flexibility is extremely limited. There are no joins, there are no ad hoc queries. You can't just write a SQL query to answer a random business question. Netflix handles this by modeling data around their queries, not their entities. If they need to look up viewing history by user, that's one table with user ID as the partition key. If they need to look up what's trending by region, that's a completely different table with the same data organized differently. Yes, they store the same data multiple times. In a relational database, data duplication is a sin. In Cassandra, it's the strategy. You denormalize aggressively so that every query is simple partition key lookup. Engineers who try to use Cassandra like a relational database, like doing multiple partition queries and secondary index lookups, end up with 200 milliseconds read latencies and wonder what went wrong. The answer is they are fighting the database design. Could they have used Postgres instead? For reads, absolutely. Postgres is fantastic for flexible queries. But at 3 million writes per second, a single Postgres instance would fall over. Even with read replicas, connection pooling, and partitioning, you would need an army of Postgres instances and a complex sharding layer. Cassandra gives you that horizontal write scaling natively. Instagram's challenge is different. Think about what the app needs to do. Show you a feed of posts from people you follow. Load a user's profile with their post count and follower count. Let you search for users, show comments on a post sorted by time or popularity, and handle likes, follows, and DMs. These are highly relational queries. A feed requires joining posts with follow relationship. A profile needs aggregating counts across multiple record types. Comments need sorting and pagination. Instagram chose PostgreSQL, and they ran their entire backend on it for years with over 1 billion users. This surprises a lot of people. Surely, at Instagram scale, you need some fancy distributed NoSQL system. Not necessarily, and here is why. Instagram's workload is read heavy. People scroll feeds far more often than they post. And the queries they need are exactly what PostgreSQL excels at. Joins, aggregation, complex filtering, sorted pagination. If they'd use Cassandra, they'd have to pre-compute and denormalize every possible query pattern. That feed you see, it would need a separate materialized table. Search, another table. Follower counts, pre-aggregated in yet another table. Anytime a product manager wants a new feature that queries data differently, the team needs to build a new denormalized pipeline. With Postgres, you write a new query, done. Now, running Postgres at Instagram scale isn't trivial. They didn't just spin up a single DBR file large and call it a day. They used an aggressive combination of techniques. Starting with connection pooling. They implemented connection pooling with PG Bouncer to handle thousands of concurrent connections without overwhelming Postgres. Read replicas to distribute read traffic across multiple instances. Partitioning to split massive tables into manageable chunks. And smart indexing to make sure the most common queries hit indexes and never do full table scans. The lesson here is powerful. You can stretch any database far beyond its intended limits with good engineering. Instagram proved that you don't need to reach for distributed NoSQL just because your user count is high. If your access pattern are relational, use a relational database and invest in making it scale. That's it. Instagram doesn't use Postgre for everything. Their messaging system, their real-time notifications, their analytics pipeline, these all use different storage systems optimized for those specific patterns. The key is that they didn't prematurely abandon Postgre for their core use case just because someone told them SQL doesn't scale. Now, Twitter's core challenge is the timeline. When you open Twitter, you need to see the most recent tweets from everyone you follow. And it needs to load instantly. Not in 200 milliseconds, not in 100 milliseconds. Instantly. The timeline is a deceptively hard problem. A user might follow 2000 accounts. Each of those accounts might tweet multiple times a day. And you need to merge all of those tweets, rank them, and serve the result in single-digit milliseconds. The choice? Redis. As a cache, not a database. Twitter's answer is Redis. They serve timelines from Redis at over 300,000 requests per second per node. And the timelines are pre-computed. Here is how it works. When a user tweets, Twitter doesn't wait for the followers to request a tweet. Instead, they use a pattern called fan out on write, which I've covered in a previous video. The tweet gets pushed into the Redis timeline cache of every follower. So even when you open Twitter, your timeline is already assembled and sitting in memory, ready to be served. Redis makes this possible because it operates entirely in memory. There is no disk read, no query parsing, no index lookup. Your timeline is a pre-built list sitting in RAM, and reading it takes microseconds. But here's the thing that separates good engineers from the ones who lose user data. Twitter never treats Redis as the source of truth. Redis is a cache. The actual tweets are stored in a durable database. The architecture follows a pattern you'll see at almost every large company. Write to the durable store first, then replicate to Redis, read from Redis. If Redis fails, fall back to the durable store. This is critical. Companies that skip the source of truth step and use Redis as their primary database eventually write a postmortem title, How We Lost 2 Days of User Data. Redis by default can lose data on restart. It's designed for speed, not durability. Now, there's a fascinating edge case in Twitter's architecture. What happens when someone with 80 million followers tweets? If you fan out on write, that's 80 million Redis list updates for a single tweet. That's insanely expensive. Twitter handles this with a hybrid approach. Regular users get fan out on write. Their tweets are pre-pushed to followers' timeline. But celebrity accounts with millions of followers, use fan out on read instead. So when you open your timeline, Twitter merges your pre-built timeline from Redis with real-time lookups of tweets from celebrity accounts you follow. This is the kind of nuanced architecture decision that separates real system design from textbook answers. There is no one-size-fits-all solution, even with a single feature. So what's the takeaway? How do you pick the right database for your system? It comes down to 3 questions. First, what's your primary access pattern? If it is flexible queries with joins and aggregations, lean relational like PostgreSQL. If it's massive write throughput with predictable key-based reads, look at Cassandra or DynamoDB. If it is ultra-low latency reads of pre-computed data, Redis as a caching layer. Second, what are you willing to sacrifice? Every database optimizes for some things by giving up others. PostgreSQL gives you flexibility but struggles with massive write throughput. Cassandra gives you write scale but takes away query flexibility. Redis gives you speed but sacrifices durability and storage capacity. Third, do you actually need it? This is the most important question. Most systems don't need fancy databases. A well-indexed PostgreSQL handles more load than 95% applications will ever see. Don't choose Cassandra because Netflix uses it, when your app has 10,000 users. Choose it when you actually have the access pattern and scale that demanded. Netflix, Instagram, and Twitter all made different database choices, and they were all right because they weren't picking the best database. They were picking the best database for their specific access pattern. And that's the real skill in the system design, not memorizing which database is fastest or most scalable. Understanding your data, your queries, your trade-offs, and then matching them to the right tool. If this is the kind of deep system design thinking you want to master, do check out my System Design Mastery course. I go into these architectural patterns in much more detail, with hands-on examples you can use in interviews and on the job. Link in the description, and if you found this video useful,
today, I'm going to be showing you guys 2 different ways that we can run Claude Code for free. The first way is going to be by running the LLM locally on our own machine. And then the second way is using Open Router. Both of these ways are extremely easy, a lot easier than you would think. And I'm going to walk you through step by step both of them. And my goal is to cover everything that you need to know in order to run this and answer any questions that you may have. So let's not waste any time and just get straight into the video. All right, so before we get into the tutorials of the 2 methods, there is some important stuff that we need to cover. The first one is about what actually is Claude Code. And when I say how do you use Claude Code for free, what does that mean? Access them is through the company's API, which means in order to hit their API, we have to pay them for model. We're going to be using Ollama, and then we're going to hook that up into this place where I have to authorize myself into my Anthropic account. Same thing with the Max. So that's the thing that you have to realize is that there's really no such thing as free, because if you want to run a really good model locally, then you need the hardware to support it. If you want to run it on the cloud, you either have to pay for a subscription like Ollama, or you could pay for a VPS that's big enough in order to host that model there. So that's a trade-off. There's really no such thing as free. You got to find the balance between quality and price, and also thinking about like where you make the coding side. It can definitely be some simple tests, project settings. So in the .claude, in the settings.local.json, you can see that this is what I have. I've got some permissions and stuff like that. I've got an environment variable, but we need to add a few more environment variables. All right, so I switched into a different project just so I could keep this clean, but I have this other JSON file right here called free router. So what I'm going to do is I'm just going to take all of this and copy it, and then I'm going to open up Claude, and I'm just going to say, hey, can you please add this configuration to our settings.local.json? And I would go ahead and paste that right in here. Now, in my case, my API key is in there. So just be aware that if you do this, Anthropic is reading that. But the reason I'm doing this is because right after this video, I'm just going to delete this anyways. So now let's talk about what this is doing. So the first thing is it's pointing to Open Router instead of Anthropic. And then in the Anthropic auth token, this is where you put your Open Router API key. So I know it says Anthropic, but this is where you put your Open Router one. So you'd go into your Open Router account, you would go over here to credits, and then you're going to go into your API keys section and you're going to create a new key. So give it a name, hit create, and then when it gives you that value, you're going to copy that, and then you're going to put that into the configuration that I just showed you right here, Anthropic auth token. And then the Anthropic API key, you're going to leave completely blank. The Anthropic model and all of these other models, you're going to put in a free model from Open Router. Now, the reason you have to do all of them and not just this one, like the Open Router documentation suggests, is because if you do it like that, it's actually going to, by default, call on Anthropic paid models for Haiku and Sonnet. So here in my logs, you can see I was testing this out and I did the free configuration, but then I noticed in my logs, I kept getting charged by Haiku. And I was very confused because whenever it was doing little tool calls or doing little file searches, it was using Haiku instead of using the free models that I had installed it to use. So if you were to have just put in this configuration and you would have left out these variables down here, then it would have by default used Sonnet or Haiku for basically all of these things, and it would have charged you without you even knowing. So make sure you put these ones in there as well. And then you can see after I figured that out, it was able to use all of these for tool calls and everything instead of using the paid models. The only reason these were paid is because I did that intentionally. But yeah, this is what Open Router says, so just do it the way that I did it. So now that we have this set up, if I actually open up a terminal and I type in Claude, what do we see here? We see that we are using Open Router free API billing usage rather than using our max plan or our team plan. So what is Open Router free? Okay, well, this is very similar to Ollama. You've got all these different models you can look at. When you click on a model, it'll show you the price per input tokens and the price per output tokens. But what you can do is if you come up here and you just search free, you can see that there's a ton of models right here available that are free. And if you go down to the actual Open Router one, which is right here, the free models router. This one is completely free, but it basically routes you to whichever model is like the most available at that moment. So it kind of helps you from getting rate limited and things like that. Now, I'll show you how this works, but I'm also going to show you why I wouldn't recommend using this, because you just don't have any control over what model is getting called. So here I'm asking it to make a file in this folder called Open Router Test. You can see that we are able to get the visibility as far as what tools it's using, which is great. We have over here the Open Router Test file, and there's nothing in it, but it did create that, and it didn't take that long either. And now in my logs, you can see this is what we just did, April 3rd, 5:15. It called the Open Router free model 3 different times, and all of these times costed us $0, as you can see. Now let's say instead I want to use this awesome Qwen 3.6 model with a million context and completely free once again. Well, what I would do is I would copy this model name, so Qwen 3.6 plus :free. Back in Cloud Code, I would just close out of this terminal real quick. I'm going to open up the settings.local.json, and I will basically just come in here and I will paste that new model name into all of the instances where we said Open Router free. And now after I save this and I go ahead and open up a new terminal and launch Claude, we should see that we have in here, this is running now with that new Qwen model, and I can say hello, and it should be able to respond to us fairly quickly as Qwen. There we go. Hey, what can I help you with today? If I go back into my logs and I refresh, we should see that this most recent call will be with Qwen. There we go. Those two came through as Qwen, and you can see that once again, it costed us nothing. So let's see what else we can do with our open source models. Because if you remember, I talked about some things where Anthropic has trained its Claude models to act a certain way with Claude Code, but not all the other models have done that. So can you go ahead and search the web and do some research on Google's new model, Gemma 4? So what you'll notice when I asked it to search the web, it's doing web searches and it's knowing how to use those tools, but it's running into an issue where the current model
In this video, we are going to explore how we can create high-level architectural diagram using MCP server capabilities of draw.io and xkelly draw. And to interact with these MCP servers, we are going to use Claude Desktop and Visual Studio Code. So let's get started with that. So first thing, I'm just going to open my Claude Desktop. So once you open your Claude Desktop, you need to go to in your, and first thing you can see Claude is searching. So let's see it one by one. Because we are using a Claude URL and it has created a payment kind of diagram like this. Here also actually it's a editable version. So it has opened it on the draw.io and we can just go ahead and modify things accordingly. The first option was this remote MCP server. If you want to just try it out, where you want to see the diagram in the inline chat, then I cannot do it on the Claude Desktop. We have to do it on the web version. But rather than doing over there, I'm just going to do it in the VS Code. So in the VS Code, if we have to add like any kind of MCP server, then we have to just click on Control Shift and P. I'm on Windows. And here I just have to say add server. And you can see like all these options because this is going to be the remote server. So I'm just going to select this HTTP and it's saying like URL of the MCP server. So here I can just say this is going to be the URL and I can just pass it over here. And then it's saying enter server ID. I'm just going to say draw.io. And you can see like it has created a configuration like this. It's going to come up with 3 tools. I'm just going to start the server. And here we do have like one particular tool available. So let me just open GitHub Copilot chat and let's chat with this particular server. So I can just pass the same prompt, but instead of xkelly draw, I'm specifically asking to use draw.io. Now it's trying to create a diagram for us and you can see like it has created it using draw.io MCP server. In this case, it's coming inline because it is rendering MCP app. And as mentioned over here, if you are using this particular remote MCP server, then the diagram is going to come inline in the AI chat interface only using MCP apps protocol. So same thing is being reflected over here. So here we are getting the diagram in the chat itself. We can zoom out or zoom in just to see a specific section, but it's not going to get opened on the web portal. It's going to be opened here only. Now the third option, what
The entire thing that you are seeing here, none of it is built by me. I did not even know something like this can be done by just talking to Telegram.
This is Banu. He built and sold Feather to Thibaut Maker for $250,000, then built SciGPT to $18,000 MRR, and now built an AI agents army with OpenCloud that works 24/7 to help him reach the goal to make 1 million ARR with SciGPT.
So like everyone just collaborates with each other. They will share findings of each and every.
If you don't know what OpenCloud is, then you will probably be blown away like I was. And if you know what it is, or if like me you just installed it 2 days ago, then this episode will show you what's possible when AI agents start working together towards one goal.
It actually signed up as a user. It went through how to create a chatbot. It figured out the entire flow, mapped it out, and then told me that, okay, these are the points the conversion might be like.
So Banu, I'm super excited to have you today because you are a serial SaaS shipper. You did a Feather that you sold for $250,000 to Thibaut Maker. You built SciGPT to 18K MRR. And right now I wanted to have you because you just built a Mission Control HQ that just reached 10K MRR. But I think the amount of money you made is not the main point. First, congrats. But I think the main point is that you jumped on a new trend that is open cloud. But for me, it's not a new trend, it's something huge. And I want to talk about that with you today. I want to talk about open cloud. So can you just explain first what Mission Control HQ does?
Yeah, so like everyone else, I started I started seeing everyone talking about this new thing called Cloudbot. So at first I just ignored it, just like, okay, this is just another okay, some new tool that came in. But one day I just I was just curious, and I just tried to, like everyone was buying Mac Minis to install like Cloudbot. So I thought, okay, I also want to buy it. But before buying it, let's try what it is to see what can I do with it. So that's when this all started. So once I started using it, it's like it's so much better than anything else I have used before. Like it has so much autonomy than anything that I have seen before. So I started using it a lot. I started building sub agents. My main open claw, it's getting confused with everything I have been saying. Like I talk about my personal life, I talk about my business, I talk about coding, marketing, sales. I do
Well, sitting on my desk is a new Mac Mini that I set up just for the purpose of running my team of AI agents using OpenClaw. I've got a developer, a marketer, a project manager, a system admin. They each have their own personality. They've got a queue of tasks tracked in this custom dashboard that I built. And I'm chatting with them in Slack, just like I would with my real team members, except they're agents powered by OpenClaw and various large language models. What a time this is. But getting this up and running was not a plug and play situation. Over the past week and many late nights, I had to figure out my answers to question after question, some technical, some strategic. Like, should I order a new Mac Mini or can I run OpenClaw on a VPS? And what's this going to cost me in API tokens? And can I use my Claude Max plan? And what chat tool is best for my agents? Telegram or WhatsApp or Slack? Should I have it power one agent or can I set up a team of agents? And am I going to need a custom dashboard for managing them? And let's not forget about security. What should my agents be able to access and how should I think about safeguards? And most importantly, what's my use case here? What will I have my team of agents actually do for me? So today I'll share where I've landed on all of those questions and I'll show you my setup for all of it. To be honest, I didn't see the appeal of OpenClaw at first. Back when it was called ClaudeBot and then Moltbot, and it was buzzing around Twitter a couple weeks ago, everyone was talking about having their agent respond to their emails for them or book flights or order takeout. And I don't want or need an AI agent in my personal life, and I don't even want it to manage my calendar. But then I started thinking about a real challenge that I've been having in my business and how setting up OpenClaw could help me solve it. I run this YouTube channel and Builder Methods Pro and my courses and a weekly newsletter. And thanks to things like Claude Code, of course, building things has never been easier, but building it is only half of what I do. I develop training content, I manage a publishing pipeline, and I oversee my membership business. But lately I've been bottlenecked. There's so much more that I want to create and deliver if only I had the bandwidth. In my past businesses, I solved this by hiring real teams and building processes to help us scale. And that worked, but the overhead was real too. So when I gave OpenClaw another look, I asked a different question. Not, do I want a personal assistant, but what if this could fill roles on my team? And now I'm convinced that this paradigm, autonomous agents with defined roles running on their own machines, I think this is here to stay. Now, OpenClaw is just the first generation of what I think will be much bigger. So I want to be figuring this out now, and maybe this video can help you get started too. All right, so what actually is OpenClaw? It used to be called ClaudeBot and then Moltbot. And how is this actually different from how you might use Claude Code or any other agent? The core of OpenClaw is what's called the gateway. That's a process running on a machine, which shouldn't be your personal machine, but we'll talk about security in a moment. The OpenClaw gateway can run tools, it could use a browser, it can execute bash scripts. Of course, Claude Code can do a lot of that too. But what makes OpenClaw different is that it's always on. It maintains a persistent workspace with memory and session logs. So you can chat with your agents through Telegram or Slack and delegate tasks that they can do on their own in the background. So that's a fundamentally different paradigm from you personally managing Claude Code sessions in your terminal. OpenClaw is closer to having teammates who do their work on their own workstations. The first question is, where should this thing run? Now, I don't recommend you run OpenClaw on your daily driver machine. You don't want to give it unfettered access to your files and your accounts. And even if you isolate it with something like Docker, your machine would need to be on and awake 24/7 for your agents to work. So OpenClaw needs its own dedicated machine. That could be a cloud VPS starting at around $5 a month, or it could be a physical machine. Doesn't have to be a Mac Mini, any kind of computer on your network. Both are valid, and a lot of people are doing well with the VPS setups. But I went ahead and I spent the $600 on a new Mac Mini M4, and call me old school, but I like to be able to screen share into it, see the desktop, install things, and manage it visually. And I SSH in too when I just need to run a quick command. And if I end up using my agent team for all the use cases that I have in mind, I'll need more storage and bandwidth than the cheap VPS tiers offer, so the cost would start to balance out anyway. And hey, if none of this works out, I'll throw that Mac Mini up in my home music studio. I'll use it up there. So I've got the dedicated machine, but that's just the first layer. I need to think carefully about what my agents can and can't access. Now, this is where the hiring metaphor really kicked in. If I'm bringing someone onto my team, I wouldn't give them access to my personal laptop or let them loose on a browser where I'm logged into everything. No, an employee would get their own machine, their own email, access to the files and services that they need with the right permissions, nothing more. So that's what I did. I set up a dedicated email address for my agents. I created a GitHub username that I can invite to specific repos. I can grant and revoke access to services just like I would with any other team member. Now, files were a bit trickier. I want easy two-way syncing between my computer and the OpenClaw workspace on the Mac Mini, especially since I'm developing a brain system where all my business activity gets logged into Markdown files that my agents can access and work with. More on the brain maybe another time. So all my files live either in GitHub repos or my main Dropbox account. But I don't want to just share my personal Dropbox with OpenClaw. That gives it access to way too much. So I had OpenClaw set up its own Dropbox account. And so the specific folders that I want to share between my main Mac and the OpenClaw Mac Mini, both Dropbox accounts have access to those. And so everything else stays walled off. All right, let's talk about costs, because if you're not careful, you can easily run up hundreds or even thousands of dollars in token costs just chatting with your agents and running tasks. I blew past $200 in the first 2 days of setting up my system. Now, I already pay for a Claude Max plan, and I was hoping that I could just use that. But then I heard the stories of accounts being shut down because this type of usage might be against Anthropic's terms of service.
And then within a few days, he upgraded to the $200 subscription. Or euros, because he's in Austria. And he was in love with that thing. That for me was like a very early product validation. It's like, I built something that captures people. And then a few days later, Anthropic blocked him because based on their rules, using the subscription is problematic or whatever.
So there's real ambiguity. ambiguity there, and I genuinely wish that there would be some official word, one way or the other. Now, I intend to play by the rules, so here's where I landed. My Claude Max plan stays for my personal use with Claude and Claude Code on my devices when I'm working. My OpenClaw agents use API tokens, completely separate. I'm running those tokens through OpenRouter, which centralizes all my API usage and makes it easy to select from hundreds of models and providers. More importantly, it lets me carefully optimize which agents use which models for which tasks. Honestly, that optimization is probably where I spent the most time this past week, just figuring out which tasks need the power of Opus and which can run on cheaper, faster models. Still, running this team of agents is not cheap. And if you've been building with the frontier models, then you already know this isn't a free ride. And from a business standpoint, if you compare the token costs to the cost of hiring multiple team members to do the work that can, maybe should, be delegated to agents, the ROI math gets pretty compelling. Now, to the question of chatting with my agents. OpenClaw supports a wide range of chat tools. I started with Telegram since that was the easiest to get up and running. It worked for a few days, and I was even able to set up separate Telegram bots for each agent. I'll talk about my multi-agent configuration in just a minute. But after a few days on Telegram, I found the interface just wasn't comfortable, especially when agents would send me markdown formatted content, which kind of works, kind of doesn't. So again, I'm working with my agents like I tend to work with teammates. And my teams have always used Slack. So I set up Slack bots for each of my agents, and that was super easy. And Slack has great markdown support, and I really like how we can use threaded replies. And that makes it easy to manage multiple agents with multiple requests and responses flying around. Now here's what made OpenClaw really click for me. Instead of using it as a single agent, I set up a multi-agent configuration so that I can build an actual team of 4 agents. Claw is my system admin, who I work with when I'm tinkering with my OpenClaw system itself. Bernard is my developer. Val works on marketing tasks, and Gumbo is my general assistant. Each agent runs as its own Slack bot with its own conversations, and I experimented with having them all in a group chat, which kind of works, but has some quirks. So I assigned a default model to each agent. Opus for Bernard, the developer, and Claw, the system admin. That's where reasoning power really matters. And then Sonnet for Val, the marketer, and Gumbo, the assistant. That's where speed and efficiency make more sense. But I often direct them to delegate parts of their work to sub-agents for tasks where I need to specify a more expensive model or a cheaper model. Now, I decided to have them all share one workspace, which means they all access the same memory, and I can manage configurations and agents MD directives all in one place. Also, my brain folder lives in this workspace, and that's where all of our work gets synced up. And if you want to hear more about my productivity system with my agents, let me know in the comments, and I'll make another video all about that. Now,